Okay, so Mr. Fies is found dead at 7:30 p.m. with a body temperature of 80 degrees Fahrenheit. By 8 p.m., his body temperature is at 75 degrees Fahrenheit with a room temperature of 70 degrees. So we have to find the hour that Mr. Fies met his untimely demise. So given here the ambient temperature, the initial temperature, the temperature after time, which would be half hour, we would put this into Newton's law of cooling, which would be 75 equals 70 plus 80 minus 70 with e to the power of k times t. So now we have to solve for k. So we would now subtract 70 from this side and 70 from this side, which would give us 5. Now we solve what's in the parentheses, so 80 minus 70 would be 10, which would give us 10 multiplied by e to the power of k. So now we have to divide out the 10 from both sides. I divided 10, divide by 10. So now we would have 5 over 10, which would be 1/2, equal to, which we would move the k in front of the e, and then now we would just add natural log. So it should be natural log of 1/2 equals k multiplied by the natural log of e, which the natural log of e is equal to 1, so we can cancel that out. So now we just have to solve for the natural log of 1/2. So if we put it into our calculator, ln 1 divided by 2, which would give us negative 0.69314711806. So it's a bit long, so what I'm going to store it into the calculator. I'm going to store it as variable x. So it's now stored. So now what we do here is we would plug this into k into our other equation and solve for t, which would give us the time. So now we have a new sheet of paper. We would now put in 80 equals 70 plus parentheses 98.6, which is the average human body temperature, so when Professor Fies was alive, minus 70 to e the power of variable x, which I stored, multiply t. So now we would repeat the steps again. So minus 70 in this side, which would give us 10 equals, now we just solve what's in the parentheses, which would be 28.6 multiplied by e power of x times t. So what we do is we do the same, just divide out the 28.6 and 28.6 would be 10 over 28.6 equals, so x times t times e, which would now do the natural log of 10 over 28.6 equals x t, now ln e of e, which would be just 1, so it would cancel that out. So now we have to get rid of the t, so our x being 0.69314711806, we just divide it out. So now we would just solve for ln 10 over 28.6 all divided by x, which is our stored variable, equals t. So when we put it in the calculator, so ln 10 divided by 28.6, divide that by variable x, would give us 1.51. So what would we do with that? So this gives us an hour and a half, which would easily translate to 90 minutes. So given this, let me grab a sheet of paper. Given 90 minutes, we would then subtract that by the time we found him dead, which would be at 7:30. So if we put 7.5 minus 1.5, which would give us, so let's see here, let me just write it out for you. Which would then give us 6 o'clock p.m. So he was murdered 90 minutes before we got there, which would lead our final answer of 6 p.m.